Hey guys, Mr. again. Today we're going to look at solving a system of equations, and we're going to look at how there's three possible solutions. Alright, so solution type number one. This is what we're most familiar with. Most of the problems that we've seen, this has happened, where we've had a system of equations, two or more equations, and the solution is the intersection. So we have an equation y equals 2x minus 4, that's the blue line, y equals negative 3x plus 1, that's the red line, and they intersect right there, and their solution is a point. Okay, we call this consistent independent. Okay, just a term that you need to know. When the solution is one point, there's an intersection at one point, we call it consistent independent. That's what we're most familiar with. Alright, solution type number two. Here's the equation for the blue line. Here's the equation for the red line. They don't intersect at all. And of course we know that they don't intersect at all because they have the same slope. So here, there's no solution. Our first example, there's one solution, a point of intersection. Here, no solution. Those lines are never going to intersect. We're never going to see a solution. So no solution. We call this inconsistent. When there's no solution because the lines are parallel, that would be called an inconsistent system. And our third solution type. You have to look real close, but we have this blue equation, y equals 2/3 x minus 1, right there. And then we have this red equation, negative 2x plus 3y equals negative 3. And that's actually right on top of it. So it's like two lines on top of each other. And of course what that means is they're really both the same line. And if you look at the equations, you might not see it right away. But if you take this equation and you put it into slope-intercept form, you will get that equation. They end up being the same thing. Okay, so sometimes they don't look like it at first, but they end up being the same exact equation. So in this case, we have an infinite number of solutions because it's every point on the lines. And for this, we call it consistent dependent. Okay, so just to go over those three real quick. Solution number one, they intersect at a point. One solution, consistent independent. They don't intersect at all. There's no solution. We call that inconsistent. And where the lines are actually the same, they're on top of each other, we know there's an infinite number of solutions, and we call that consistent dependent. All right, good luck.